We are going to look at solving linear systems using elimination. Like when we did it with substitution, I provided you the steps. One of the things I said was the steps may not make a whole lot of sense until we've gone through a few examples. So I'm not going to spend much time talking about the steps right now. Instead, we'll use the steps in the actual questions themselves. So here's the first question. Solve this system using elimination. So what we want to do here is we want to look at the numbers in front of like variables. In other words, what are the numbers in front of x's? Well, we have an 8 and we have a 4. What are the numbers in front of the y's? We have a 3 and we have a -1. What we want is we want both of the yellow numbers to be the same, or we want both of the green numbers to be the same. And when I say I want them to be the same, they can be 8 and -8, or just both 8. So the sign doesn't really matter right now. We just want the numbers themselves to be the same. So the question is, can we do something to either equation 1 or equation 2 to make that true? And when I say do something, what we are doing is we are either multiplying or dividing. So can we multiply or divide one of these equations? We're going to have to multiply equation 2, because whether we go with the x's or the y's, both of those coefficients, both of those numbers in front of the variables, are smaller than the ones in equation 1. So we know for sure that we are going to multiply equation 2 by some number. But do we want to get rid of the x's or do we want to get rid of the y's? Because the name of the game is elimination, and we are going to eliminate either the x's or the y's. Well, it doesn't matter which one you pick. So let's pick x. We're going to multiply. So if we want to get these numbers to be the same, then we have to multiply the 4 by what? 2. So we're going to multiply equation 2 by 2. That gives us a new equation. 8x minus 2y equals 78. We multiplied all terms by 2. And now we have equation 3. So what we're going to do is we're going to do something with equation 1 and 3. So what do I mean do something? Well, here's equation 1. 8x plus 3y equals 33. Here's equation 3. 8x minus 2y equals 78. So we've got equation 1 and equation 3. My question to you is, if we want to get rid of the x's, do we add or subtract? Well, if we look at the x's, we have +8 and +8. So if we add those together, we get 16. We're not getting rid of it. But if we subtract, 8 minus 8 is 0. So it's going to be 1 minus 3. So 1 minus 3 means we subtract all of the x's from the x's, the y's from the y's, and the numbers from the numbers. So 8x minus 8x, nothing, zippo. That's what we're trying to do. We are trying to eliminate. 3 minus -2, minus makes a plus, we get 5y. And 33 minus 78 is minus 45. 5y equals -45. Now, all we need to do is divide both sides by 5, and we get y is -9. So y is -9. Now we need to find out what x is. So we need to substitute y equals -9 into one of the original equations. Doesn't matter which one. So sub y equals -9 into equation 1. Equation 1 is 8x plus 3y, which is now negative 9, that equals 33. Now, 8x minus 27 equals 33. 8x, bring the 27 over to the right side, add it to the 33, you get 60. So x is going to be 60 divided by 8. Now, it doesn't work out to be like a whole number. It actually works out to be exactly 7.5. 7.5, that sounds kind of screwy. Did we do it right? Well, if we want to check if we did it right, guess what we got to do? We got to check it. And since we just used 1, we are going to check 7.5 and negative 9 using equation 2. So, equation 2 is 4x minus y, right side is 39. So that's 4 times 7.5 minus negative 9. That's 30 plus 9, which is 39, which is equal to the right side. So the answer is 7.5 and negative 9, and that is the solution. So that's how you do this question. There's definite elements to the elimination method that are very similar to substitution. Absolutely, very similar. Elimination works more easily more times than not because you can always use elimination. Substitution is only easy to use if one of the coefficients on the variables is 1 or minus 1. It's not always the case. So let's do another example. Again, what we want to do is get the coefficients to be the same. In this case, though, that means that we're going to have to multiply both of the equations, not just one. So probably the easiest way of doing it is to focus on your y's. Because if you focus on your y's, you need to think of the lowest common multiple of 10 and 15. It's 30. 10 goes into 30 3 times. 15 goes into 30 twice. So if we make those both 30, we'll be able to deal with them. So we are going to do two things at once, I suppose. We're going to multiply equation 1 by 3. That makes that 30. And we're also going to multiply equation 2 by 2. So the new one is going to be 27x plus 30y equals negative 3. And the new 2 is going to be 24x plus 30y equals negative 36. That is the new 3 and the new 1 and the new 2, which we could call 3 and 4. And because they both have 30s and they're both positive or they both the same sign, then it would make sense to subtract these two equations. So we can go ahead and go 3 minus 4. And if we go 3 minus 4, well, I mean, it's kind of a waste, but we kind of have to draw these out again. I could kind of cheat a little bit here. And there we go. If we're going to subtract them, there we go. What do we get? We get 3x. We get nothing for y, because 30 minus 30 is 0. And over on the right side, we get 33. That's positive 33. X is going to be 33 divided by 3, and x is 11. So we're halfway there. We know one part of the coordinate. Now we need to find the second one. Okay? So what are we going to do? We're going to plug x equals 11 into one of those original equations. Last time we picked 1. Hey, this time we'll pick 2. So sub x equals 11 into 2. And why we're doing that is we're looking for y now. So 12 times 11 plus 15y equals negative 18. 12 times 11, 132, plus 15y equals negative 18. If we bring the 132 over to the right side, it becomes negative. If we combine it with the 18, well, we're going to get minus 150. So we have 15y equals a negative 150. Y is going to equal negative 150 divided by 15. So if we do that dividing, we get negative 10. Y is negative 10. We do have to check it. And since we did 2 for the finding of at y, we must use equation 1 for our check. So we're going to check using equation 1. And what we're checking is the point 11, negative 10. And we're going to use equation 1 to do that. So equation 1 is 9x plus 10y. Right side is negative 1. So let's see if it works out. 9 times 11 plus 10 times negative 10. That's 99. Oopsies, I didn't write that out properly. Let me fix that up. That should be 10 times negative 10. 99 minus 100, which as we know is equal to negative 1. So your left side is equal to your right side. And that also tells us that 11, negative 10 is the solution. So that is the solution to that linear system. Okay, we have one more example to do. Here it is. We've got fractions. So how do we deal with these? Again, what we need to do is focus on eliminating the fractions. So if we look at the first equation, we have a 3 and a 2. How do you get rid of fractions? Well, you need to multiply by the lowest common multiple. What's the smallest number that 3 and 2 go into? It's 6. So we need to multiply that whole equation by 6. So what's going to happen? Well, we're going to go 6 times that, 6 times that, and 6 times that. So we have 6 over 3 in front of the x. 6 divided by 3 is 2. So this now is going to be 2x. Likewise, 6 divided by 2 is 3. So that's 3y. And 16 times 6 is 96. So the equation becomes 2x plus 3y equals 96 if we multiply everything by 6. Likewise, for the second equation, we're looking for the lowest common multiple. In this case, it is actually 12. So we're going to multiply everything by 12. When we multiply the first bit, 12 over 2 is 6. So it's going to be 6x. 12 over 12 is 1. So it's just going to be plus 1y or just plus y. And 16 times 12 is 192. So now, these two equations that we've just sketched out in black represent, and really, honestly, we could call this equation 3 and call this equation 4, because in all actuality, 1 and 2 are what we started with. But we are going to use equation 3 and 4 as the ones that are going to drive what we do. But our next step is we want to make sure that either the numbers in front of the x's or the numbers in front of the y's are the same. And maybe the easiest way to do that would be to multiply equation 3 by 3. In other words, take this equation and multiply it by 3, because then we'll have 6x. So let's go ahead and do that. So we're going to multiply equation 3 by 3. And that's going to give us 6x plus 9y equals 96 times 3 is 288. And we'll call this now equation 5. Well, the thing of it is that equation 5 and 4 both have the same number in front of x, so we can subtract them. And everything else in equation 5 is bigger, so it makes sense to go equation 5 minus equation 4. So that's 6x plus 9y equals 288. That's the equation 5. And 6x plus y equals 192. That's your 4. If we subtract these, we get 8y equals 96. Y is going to be 12, since 8 goes 12 times into 96. That gives us half the question. We now have to substitute that into one of the original equations. So let's go ahead and plug it right into equation 1. So we can sub y equals 12 into equation 1. X over 3 plus y over 2, so that's x over 3 plus y, which is now 12 over 2, equals 16. That's x over 3 plus 6 equals 16. 6 over to the right side, and that's going to be 10. So x over 3 equals 10. X is going to be 3 times 10. So x is 30. So x is 30 and y is 12. That's what we have to check using equation 2. And that's our last step. So check the point 30, 12 using equation 2. So left side equals x over 2 plus y over 12. X over 2 plus y over 12. And if everything goes all ducky, the right side is equal to 16. Is that right? Yeah, that's right. So x is 30, so 30 over 2. Y is 12, so it's 12 over 12. So we get 15 plus 1, which is 16. So the left side is equal to the right side. And more importantly, the point 30, 12 is the solution.